There we go. Am I recording now?
Yes, sir.
So see, folks, generally when I teach you, I just teach. But this will be the time that you will see I will be using notes. Okay? Right there. And for those people at home or, watching because of our COVID, there it is. Now, before the holiday, I taught you how to find E by adding up a bunch of numbers, right? I also taught you how to find pi by adding up a bunch of numbers. And those are really more advanced than this. This is about series and sequences that are, they're just two, go ahead, thank you, sir. Just two types here. Okay, remember, sequence would be like 1, 5, 9, 13, and 4, 17, comma, dot, dot, dot. Series would be 1 plus 5 plus 9. Guess what? You got to go check in. Sorry, I played as long as I could. And that's a series when you add them up. Okay? The sequence is just when you have a list of them. A series is when you're adding them up. Now, this particular one that I just did, and I could probably mispronounce this. It's called arithmetic. I used to call it arithmetic, but it's not arithmetic, it's arithmetic. Arithmetic, arithmetic, and then arithmetic. And this arithmetic series or sequence right there, I'm going to tell you how to recognize them. The way you recognize them is look at the difference between these two numbers. How much did you add right here?
4.
How much you add right here?
4.
4. These arithmetic are known because you're going to either add or subtract the same amount every time. Okay? You're either going to add or subtract the same amount. Now, every time. That is called the difference. That's going to be called D. That's always going to be called a little d, difference. Add or subtract the same amount, we're going to call that D in all of our formulas. Okay? A sub 1 is always going to be the first term. A sub 1 means first term. First term. Okay? All right? Is that cool? Give you a little information. You already knew that from the other day when we talked about the terms and when we were doing the ones we were adding up, right? It's first term. Now, let's just look at this. This would be first term, second term, third term, fourth term, and that'd be what? Fifth. So that would be A sub 5. A sub 5 equals what? 17. The name for it is A sub 5. The amount is what? 17. A lot of times people want to make this an amount, like 5 is the amount. No. A sub 5 means it's the what? Fifth term. And the fifth term value is what? 17. Guess what I mean when I write A sub n? I just mean all of these, and then that just stands for, you put the number there for the specific one. Is that okay? All the terms. A of n would mean, like, how would you find first term, second term? You put a 1 in there, you get the first term. You put a 5 in there, you get the what? Fifth term. You put a 10 in there, you get the what? 10th term. And that's what the little A of n means. All right, well, with that in mind, I got the formulas for this. If you ever want to know the 10th term, the 11th term, or the 12th term for arithmetic, here's the formula. You take the first term, A sub 1, plus whatever term you're looking for, minus 1 times the difference. And that will always tell you a term in an arithmetic. Okay? So, in the case of this one, right here, notice if you don't have this formula, you can't do anything. This is one of those, if you got the formulas, life's good. If you don't have the formula, thank you, miss, life is bad, okay? All right? Now, here we go. So, if I want to know the 100th term of that, I want to know the 100th term. A of 100 would equal what the first term is, which in this case is a what? 1 plus 100 minus 1 times the difference. And what's the difference here? 4. What you always want to do when you're looking at these is determine what kind they are. There's a lot of different kinds of series and sequence. And what I always look at is to see, I'm doing the same thing there, 4, 4, 4, adding 4, right? So I know that's arithmetic. Okay? And then I simply work that out. You can work that out, right? And I'm not going to, 1 plus 99 times 4. And there you go. 396 plus 1, 397. 397. And that's a cool, quick way to do it. And what that does is that keeps you kind of sit there on your calculator and do what? Plus 4, plus 4, plus 4, plus 4. When they ask this question on the ACT test, somebody says, well, I can do it on my calculator. Yeah, but you're going to be sitting there all day doing what? Plus 4, plus 4, plus 4. So, there you go. And that's the easy way to do it. Now, if everybody's got that formula, I'm about to give you another one and I need the room to work. All right. Say you wanted to add up the first 100 terms. You wanted to add up every term, 1 plus 5, 17, 21, 21, 25. You want to add all those terms up to that 100th term. A of 100 equals what? 397. You want to add them all up. Fair enough? Okay. Show you how to do that. You have a sum formula. S of n. S for what? Sum. Now, I'm going to give you 2 of these formulas. N, how many terms are you adding up? And then a sub 1 plus a sub n divided by 2. And I like this formula as long as I know what that last term is. See, got that last term. I worked it over there. How much is that last term for a for 100? 397. So if I want to know the sum of the first 100 terms, 100. First term was a 1. Last term was 397. And I'm going to divide that by 2. Now, every once in a while I have a student say, Mr. Jones, it won't work if that turns out to be odd. Yes, it will. Because if that turns out to be odd right there, that's going to be even right there, and it'll still work out to a whole number. Because you know if you're adding up all whole numbers, you better get a what? Whole number. It'll work. Now, half of 398. See, I'm on film now, and I can't even come up with this. This is 149. 199. Thank you, sir. Times 100. And there you go. Okay? Now, some students just survive knowing those 2 formulas, which is fine with me. They ask you, let me give you another one. Let me do another one. Everybody happy so far? All right. Now, I'm going to make up another one. I'm going to do this. negative 21 plus negative 11 plus negative 1 plus 9. That's not what I should have done, but that's okay. Plus dot, 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 dot. And I'll look at it, and the first thing I want to do is determine, to make sure it really is arithmetic. And here's the catch on that, because see, later on, we're going to have other types, all right? But for right now, since I'm teaching you, we have to just teach you the first type. How much did I add to get from here to here? How much did I add to get from here to here? 10, 10, 10. So D equals 10. That's one of the things I always want to do, is find out what does D equal. Now, I just tell you right off that I want the sum of the first 38 terms. Well, 38. First term's negative 21 plus blank over 2. Do you understand that you're going to find the number that goes in that blank? Right? And to find the number that goes in that blank, what you want to do is go over here and just use your formula. A of 38 equals first term, negative 21, plus 38 minus 1 times the difference. The difference was what? 10. And that's, if you only know these two formulas, that's what you always have to do. You have to go over here and do this and put it into that blank. Okay? And I don't mind doing that. I think it's a pretty smart way to do it. And that's probably the easiest way to do it. $370 minus 21 is 9. Okay, 349. Put it right there. Start, working. Okay? Is that all right? And then that's the way to do it. Now, we'll put a little formula over here and we'll put a star by it, because you really don't have to know this formula. This is optional. This is optional. This is a little optional formula if you just want to write it down. Especially if you're allowed to use your notes, because it keeps you from having to do this little part right here. Okay? This is optional. Optional. The sum of n terms is equal to n divided by 2, parentheses, 2 times a sub 1 plus n minus 1 times d. That combines the two formulas into one formula for you. This way you only have to know the first term of the n, and you don't have to work out what the last term is. All right, see what I'm getting at? Yeah, this combines the two formulas into one formula to begin with. Notice I picked up my sheet of paper, because I would never remember that otherwise. Okay. Now, rock and roll. There we go. Okay. Now, I know that I have arithmetic. I know that because I'm only working with those kinds. And I know the 10th term is equal to negative 21. And I know the 19th term is equal to positive 50. And since I'm just making these up, I bet we get fractions in our answer, which is okay. Okay? But notice I just didn't give you a line of numbers where you automatically know the first one, did I? What I want to know is I need to know what a sub 1 equals, and I need to know what d equals. Because if I don't know what those equal, I can't write the formula that I need. Is that all right? You notice this is the next level learning right here. This isn't just punch it in a formula and know. Okay? So, what you do is you have a sub n is equal to a sub 1 plus n minus 1 times what? D. You got that formula. So, a sub 10 would be what? Negative 21. Does everybody agree a of 10 would equal negative 21? A of 10 would equal what? Negative 21. And then you put a what right there? A what? 10. Is that okay? So, if I use that first bit of information, I get negative 21, because that's a of 10, equals a of 1, which I don't know. But I do know that the n value is now what? What am I making the n value? 10. And then I got my d. Notice I've just written an equation, right? How many unknowns are in that equation? 2. I'm going to write another equation. 50. I'm off the screen over there. Okay, 50 equals a sub 1 plus, and now that's not going to be for this one, that's going, what's that n value going to be? 19. I have two equations with two unknowns. I solve a what? System of equations. When your Algebra 2 teacher was just going nuts about teaching you how to solve systems of equations, this is why. And I'm going to go ahead and change the order a little bit. I'm going to simplify that and make that 9d. So I get a sub 1 plus 9d equals negative 21. Is that all right? Just simplify that. What am I trying to do? I'm trying to put it in the pattern that you've seen before, right? And then the bottom would be what? A sub 1 plus 18d. And I can't believe I made out a problem that nice. Equals what? 50. You solve the system of equations, and you're on your way. Probably involves a fraction. Probably involves a fraction. Is everyone really okay with writing is these two? Good? All right. Now, subtract or change the signs and add. I would change the signs at the top one and add because it makes my life easier. And I'd get 9d equals 71. So d is equal to 71 divided by 9. And that is not a good number, but that's okay. And then once I had that d, could I find a pretty easy? Yeah, I had to put it back in here. Oh man, I'm going to put it in this one. A sub 1 is equal to, a sub 1 plus 9 times 71 over 9 equals negative 21. A sub 1 is equal to negative 92. And there you go. So then you can write a formula to do everything else you would want to do. Are you really okay with that? Okay. So you write, your formula would be a sub n is equal to a sub 1, negative 92 plus n minus 1 times the difference, which is 71 over 9. And that way you would have a formula that you could use to do the rest of the work. Does everybody agree you could use this information and also write a sum formula if you needed to? Get the idea there? And this is that higher level thing, where they don't tell you the first one. If I tell you the first one and I tell you the second, third, fourth term, life's easy. It's a little bit weirder when you don't have the first one. Now, I got a student that goes, oh, Mr. Evans, what I do is I make this a sub 1, and I make this a sub 9, and I just work from there. okay, if you have to do this a whole lot and you got to find A of 38, and then you got to change all of those too. Don't do it that way. All right? Don't do it that way. Right there. All right, well, the next type is called geometric. Geometric. And I'm going to show you an example of geometric. And this is the one that I'm going to show you the really cool part about probably tomorrow. So I won't get to the really cool part of this one. Okay, let's look at geometric. These are the only two types we're going to look at this week. We're just going to look at these and do a lot with these. Geometric. Geometric. Give you an example. Okay. Am I adding 10 every time? What am I doing? I'm multiplying by what every time?
5.
5. Okay. In this case, it's always either how much you multiply by, and it's really multiply, but if you think you're, you don't, okay, let me give you an example of this. Let's say I had 21, comma 7, comma 7 thirds, comma 7 ninths. Y'all realize there I'm really multiplying by 1/3? Okay. And we call that the ratio. How much you're multiplying by, and you got to be doing it over and over. That's what makes it geometric. And in this case, we don't use a D, we use R for what? Ratio. How much am I multiplying by? What's the ratio of the first number to the next number to the next number to the next number? Ratio. So we're still going to have an A sub 1 term, but now we're going to have, instead of having a D, we're going to have a what? R. Now, on these, we're going to talk about the first two, and I'm going to put some formulas up here, and we'll even work that one. And one of the things about summing these up that you have to be careful if you're teaching this and you're just making it up as you go along, is if you get you're summing up these and you sum up a really, like the first 100 terms or the first 200 terms or something, you can get it so big your calculator spits it out and doesn't like it. Because think, you're multiplying by 5 every time, see? See, the next number is going to be over almost 2,000. See? Yeah, so you start getting huge numbers fast. Okay. I can't write in green. It makes me think of Captain Shreve, and it's just not right. Okay. Okay, to find the nth term, A sub n equals A sub 1 ratio raised to the n minus 1. Yeah. That little, remember that stuff y'all learned about exponentials, where you had the variable up there in the power place? See? Yeah. Now I'm going to go ahead and give you the sum formula while I've got it up here. S of n, and this is A sub 1, 1 minus r to the n over 1 minus r. And I'll be honest, I'm going to teach you a way to approximate this so that you don't have to do, it's an approximation, it's not exact, but I'm going to teach you a pretty good approximation for that. Now this is when you have a definite number of terms. Okay, 10 terms, 50 terms, or whatever. Okay. Now, those are the only two we're going to talk about first. And then we might get to the third. We'll see how I'm doing on time. Yeah, I'm checking my watch. First time I've taught in a while. All right, well, let's say I wanted to know the 10th term of this. I want to know A10. And then I'm going to find the sum of 10. Okay? And I'm just going to use that one right there. All right? A of 10. A of 10 equals, first term, what's the first term here? 3. Parentheses, what's the ratio here? Ratio is what?
5.
5, yeah, R equals 5. Multiply by what every time? 5. Somebody says, Mr. Evans, what if you have one that you're not multiplying by the same number or adding the same number every time? Well, then it's not what I'm teaching you today. It's something else. Yes, there are lots of these something else's. You've already seen a couple of them in the case of the little way to get E the other day and the other way to get pi, right? I just add numbers. All right. And then I do 10 minus 1. So I get 3 times 5 to the 9th. And unless you have a calculator, you just stop there. You don't have to work that out. But if you have a calculator, you can work it out. If you don't, just leave it like that. Mr. Evans puts a check by it and he's happy. Matter of fact, I think that looks a little bit prettier than 5 to the 9th, which is probably a huge number. Is 5 to the 9th, like how many digits is 5 to the 9th?
It's 1,953,125.
Yeah, see, big number, right? Okay, enough of that. Okay, now, just leave it like that. All right, so we want to do the sum of those first 10 terms. You realize that's going to be a really big number, right? Okay, let's do the sum. Okay, sum of those first 10. And you can't cheat on this one. I was going to teach you an approximation method, but you can't use the approximation method on this one. Gosh. Okay. A sub 1, 3. Parentheses. 1